Okay, so given that graph, evaluate the following definite integrals. So keep in mind that you could be asked to integrate from left to right. When you're integrating from left to right, areas that are above the x-axis will contribute a positive number to the definite integral, and areas below the x-axis will contribute a negative value to the definite integral. When you're integrating the other way, in other words, you starting at the right and integrating towards the left, then it's the opposite. Any areas that are above the x-axis would contribute a negative number to the definite integral, and any area that's below the x-axis would contribute a positive number to the definite integral. So we're given this function here, and I went ahead, even before I looked at the integrals, I just found the areas of the basic shapes that are formed between that function and the x-axis. So we have a triangle there which has an area, the yellow shaded triangle has an area of 2.5. You have a blue half circle which has an area of 2 pi. You have a green triangle which has an area of 3.75. Careful with that one. The base is 2.5 and the height is 3. So that area is 3.75. And then we have the area of that small triangle below the x-axis, and the area of that is 0.25. Part A says find the definite integral from -7 to -2 of f of x dx. Well, you're integrating from left to right, and that is below the x-axis, so your answer is -2.5. Part B, you're integrating from -2 to 0, so you're integrating from left to right. That would just be a half of the area of that blue circle, so that would be 2 pi, and it's positive because that blue circle, that quarter circle, is above the x-axis. Part C, the integral from 0 to 2 is also above the x-axis. That's a quarter circle as well. That definite integral is pi. From 2 to 5, the green triangle will contribute a positive amount to the definite integral, and the orange triangle will contribute a negative amount. So it's 3.75 subtract 0.25, which is 3.5. Any questions on that? I think it's pretty straightforward. Now is the time to ask questions if you're not understanding what's going on. Okay, the next part of that question, part E, so I redrew the diagram, and I also drew this function here that I then highlighted in yellow. So the yellow function is the absolute value of x. The reason I did that is because in part G and part H, we're not evaluating indefinite integrals of f of x, we're evaluating definite integrals of the absolute value of x. So anytime you have a function f of x and you want to get the graph of the absolute value of f of x, all you do is reflect the negative pieces in the x-axis. So you can see that the first piece from -7 to -2, that straight line, got reflected in the x-axis, and that little piece on the end got reflected in the x-axis. So now the other parts stay the same. So now that yellow highlighted function, that yellow highlighted graph there, that is the absolute value of x. Okay, so part E says evaluate the integral from -7 to 2 of f of x. So negative 7 to 2, we would take that, and now we're not looking at the absolute value function now. So maybe I should write this in here as well. This is 2.5, and this area in here is also 0.25. So when if we're integrating from negative 7 to 2, we're integrating from left to right. So I'm actually looking at this value, this, and this. Anything above is positive. Anything below will contribute a negative value to that integral. So it's negative 2.5 plus 2 pi. Now part F is the same areas, only this time we're integrating from the right. We're starting at 2 and integrating to negative 7, which is just the negative of the answer we got in E. Okay, so it's negative of negative 2.5 plus 2 pi, which is 2.5 minus 2 pi. Now, the easiest way to do this when you're integrating with these geometric shapes, when you've got areas, take whatever's above and consider it positive, and then take whatever's below and consider that negative. Okay? If you're integrating from left to right, you can just add those two. If you're integrating from right to left, you just add those two the same way, but then just make your answer negative. That's probably the simplest way to do it. So I'll repeat that again. When you have a function that's got areas above and below, the easiest way to do it is to consider that everything above is positive and everything below is negative, and then sum those two values or those multiple values. If you're integrating from left to right, that's your answer. If you're integrating from right to left, you take the negative of that answer. Now, part G, the same rules apply, only the graph is different. We're dealing with the highlighted function. So if we're dealing with the highlighted function, every area in question here is positive. So it's 2.5, pi, 3.75, and 0.25. Those are all above the x-axis now. So you can add up all those values, and if you're integrating from negative 7 to 0, you would just add 2.5 plus pi. Now, part H, you're integrating from 5 to negative 7. So that means all the way from the right-hand endpoint all the way to the start. So the best way to do that is add up all the numbers. They're all above the x-axis. So they're all positive. But now because you're integrating from right to left, you just make it negative. And you get negative 6.5 minus 2 pi. Any questions on that? Okay. Next topic then. You should, maybe some of you have printed this out. Again, I'll say that I've posted these in Edsby if you want to print them out. So we're going to talk about properties of definite integrals. Now, a lot of these properties we've already used in the previous lesson, but we're going to use them in a bit of a different way here today. So the first property that's important for you to know is that the integral from a to a. So if you start at a and end at a, that definite integral is 0, which makes sense because if we interpret definite integrals as areas, if we start at a and end at a, there is no area, there is no shape, there's no square, triangle, or anything. So that area would be 0. So that definite integral is 0. No matter what the a value is, as long as the lower limit and upper limit are the same, the value of the integral will be 0. Number 2 is just saying that if you integrate from a to b and you get an answer, if you take that same region and integrate the other way, and integrate from right to left, it's just the negative of what you get when you integrate from left to right. So the integral from a to b of some function is equal to the negative integral from b to a of some function. So that's just, that's the difference between integrating from right to left and left to right. So you can see from that diagram, if you're integrating from a to b, assuming that that area under the graph from a to b is capital A, then if you're integrating from a to b, the result of the definite integral would be a. But if you're integrating from b to a of f of x, then your definite integral would be negative a. And I mean, we just used that property in the last section, in the last example I just did. The third one is the one we'll probably use more often today. And all this is saying is that definite integrals, you can add up areas as you go along from left to right or right to left. And we did that in the last example. This is just this is just the property written down formally. So what we're saying here, if we look at the diagram, if we want to know what the definite integral is from a to d, then really we can split that into 3 integrals based on our graph. That's equal to the integral from a to b plus the integral from b to c plus the integral from c to d. That would be the integral from a to d. So you can add up the different parts, making sure that you don't skip any of them. Any questions on that? So that's the 3 properties that we're going to be using today, formally written out. Any questions? Okay, so how do we use these things? So all these examples today are pretty much taken from past AP exams or practice exams. The first one here, so you're given the graph of f of x. So I've drawn a graph of f of x there. It's the black line. And you're told that the integral, the definite integral from -6 to 0 is 1. And the integral from 2 to 6 of that function is 2. Okay, so I'm just going to move down. I've written that information here under the graph in red. We're also given that the yellow shaded region has an area of 5. The orangey peach shaded region has an area of 2. And the green shaded region has an area of 1. We're given that. So everything now in that picture or that graph, even the red integrals, that's all the information we're given. And now we're being asked to evaluate those integrals there. So I just a heads up, I've written these things out formally using full notation and everything here for those of you that are interested. But it's really just to show you how those formulas work, those properties work, but it's not necessary to write all that out to get the answer. Okay, so part A, let's go through this and I'll explain what I mean. The integral from 0 to -3. We're being asked to find that integral. And so there's a close relation. The integral from 0 to -3 is just that blue shaded region, but we're integrating from right to left. Now, whether we're integrating from right to left or left to right, the area of that blue shaded region is the same, but the answer will be either positive or negative depending on which way you're integrating. What you need to notice is that the integral from -6 to 0. So if I add up the yellow region and the blue region, integrating from left to right, the answer there should be 1. Okay, we're given that. The integral from -6 to 0 is equal to 1. Well, if the yellow shaded region is 5, what does the blue shaded region have to be if the total area from -6, or the total definite integral from -6 to 0, is equal to 1? This is not rocket science. This has to be 4, right? Because 5 subtract what number will give me a total of 1 from -6 to 0? Well, it would have to be 4, right? The 5 would contribute a positive number to the definite integral. The 4 would contribute a negative number. 5 minus 4 would give me 1, which is the integral from -6 to 0. Now, you can see that I wrote all that down. Now, the way you can do it is, if you want to write it formally, break up the integral from -6 to 0 into two integrals. You break it up from -6 to -3, plus the integral from -3 to 0. Now we know the value of the integral from -6 to 0 is 1. We know the value of the integral from -6 to -3 is 5. And we're looking for the integral from -3 to 0, or 0 to -3. But if I can find the integral from -3 to 0, then I'll just change the answer to, I'll just multiply it by -1 to get the answer of 0 to -3. So I bring the 5 to the other side, and I get the integral from -3 to 0 of f of x dx is just 1 subtract 5, which is -4. Okay? Which means the integral from 0 to -3 will be +4. Now that's a whole lot of work in writing when you can just look at the graph probably and tell me that integral would be -4. Or sorry, +4 if we're going from 0 to -3. Any questions on that? So the next one is similar. Okay. You're being asked, what is the definite integral from 4 to 6? Well, basically it's what's the area of that pink shaded region. Now, the area or the integral from 2 to 6, which is the green shaded region and the pink shaded region together, that integral is 2. So you say to yourself, what does the pink shaded region need to be if the total integral from 2 to 6 is 2? Well, it would have to be 3, because 3 plus -1 would give me 2, which is the value of the integral from 2 to 6. Now, you can write it out formally like I did there. You take the integral from 2 to 6 and break it up into two integrals. The integral from 2 to 4 plus the integral from 4 to 6. And then you sub in the values that you know. The integral from 2 to 6 is 2. The integral from 2 to 4 is -1. And the integral from 4 to 6 is what we're after. Just bring the -1 to the other side, and we get a value of 3, which is what you would get if you just looked at the graph and did it quickly in your head. Part C, what's the value of the integral from -6 to 6? I mean, that one you're looking at it and you're just adding 5 plus 2 plus 3 and subtracting the 4 and the 1. So you would get a value of 5. Without writing anything down, you can see that, right? And you're integrating from left to right. So anything above would be positive. So the 5, the 2, and the 3 would be positive. And anything below would be negative. So the 4 and the 1 would be negative. You sum all those up and you would get 5. Or you could do what I did and break it up into 4 different integrals. The integral from -6 to 0, plus the integral from 0 to 2, plus 2 to 4, plus 4 to 6. You're going to get the same answer, 5. Part D, that one's the easiest. The upper and lower limit are the same. Definite integral is 0. Part E, the integral from 4 to -6. So I'm starting at 4 and I'm integrating to -6. Which means I'm integrating from right to left. So the way I would do this is add 5 plus 2 and get 7. Then subtract 4, which is 3. And then subtract the 1, which is 2. Okay, so if I was integrating from -6 to 4, the answer would be 2. But if I'm integrating from 4 to -6, the answer would be -2. And that's the quickest way to do it. Now, if you want to write it out formally, you can see that I've done that. But that's not the quickest way to do it. You can do this from just looking at the graph. Again, I'll go through that. We're integrating from 4 to -6. Okay, so keep in mind here, you're integrating from right to left. So what you do is, everything above, consider it positive. 5 plus 2 is 7. Everything below is negative. So I'm going to subtract 4 and 1. So 7 subtract 4 is 3. 3 subtract 1 is 2. So if I was integrating from -6 to 4, my answer would be 2. And if I'm integrating from 4 to -6, my answer is the negative of that. So it's -2. Any questions on that? I think it's pretty straightforward. Okay, next examples, or next couple examples. IPE, what does that mean? It just stands for, I'm just referencing where I got these questions from. So IPE means International Practice Exam. So a lot of times the College Board, which is the organization that runs the AP exam, they issue practice exams for students or for teachers to give to students. This comes from the 2014 one. If the sign of 1 over x squared plus 1 is an antiderivative for little f, then what is the integral from 1 to 2 of little f dx? Well, the integral from 1 to 2 of little f dx is just the antiderivative, which is capital F evaluated at 2 minus capital F evaluated at 1. That's the fundamental theorem of calculus we talked about a few lessons ago. Capital F is the antiderivative of little f. Well, they tell us what the antiderivative is. It's that function there. So really all I got to do is sub 2 into that function, sub 1 into that function, and then subtract the two values. So when I do that, I get the sine of 1 over 5 minus the sine of a half. Now, you need to make sure that your calculator is in radian mode there when you're using your calculator. And you would get negative 0.281. And so that answer is A. So this would be the type of question you would see on the multiple choice portion of the AP exam. One that will allow you to use the calculator. Any questions on that one? Okay, the next one's pretty straightforward, I think. You're given that graph. Now I've gone and highlighted, I've broken it up into different shapes and I've highlighted it and I found the areas, but what you were originally given was just that function and asked what's the integral from 0 to 7, which means you have to find the net area. So I broke it up into 4 pieces, found the area of each one of those pieces. The yellow shape has an area of 3, the blue square is 4, the green triangle has an area of 1, and that pink triangle that's below the x-axis has an area of 2. So if I want to know what the value of the definite integral is from 0 to 7, okay, we're integrating from left to right, I add 3, I add 4 and 1 together to give me 8, and then I got to subtract the 2 because it's below the x-axis, and I get a value of 6, which is the integral from 0 to 7. So that value is 6. If it asked you for the value of the integral from 7 to 0, the answer would be -6. Okay, this comes from another practice exam, 2017. So when you're given this question, it seems pretty random, like why are they giving us all these integrals? But it's not as random as you would think. Pay attention to the limits and pay attention to the integrand. So in this question, all the integrals involve the same function, which is g of x. Okay. The first integral is from 4 to -10, and they're telling you the value of that integral is -3. Then they give you another integral from 4 to 6. They tell you that value is 5. And they're asking you to find the value of the integral from -10 to 6. So what I would strongly suggest, and I've written it there, is when you get questions that are like this, write all the integrals with the lower limit as the smaller number. In other words, write them so as if you were integrating from left to right. Okay, so I've taken that first integral and flipped it. Rather than writing the integral from 4 to -10, I've written it as the integral from -10 to 4. Okay, that value is 3. And then the integral from 4 to 6 is 5. So it's easier now to see there's a relationship between those two. The first one starts at -10 and ends at 4. And then it's like the next one is starting right where the last one left off at 4 and integrating to 6. So if I want the integral from -10 to 6, all I need to do really is add up 3 and 5 and I get 8. So it's much easier to see what's happening if you write the integrals as if they were integrating from left to right. So the lower limit, the smaller number is the lower limit, and the higher number is the upper limit. So the integral from -10 to 6 is just the integral from -10 to 4 plus the integral from 4 to 6 of g of x. And that's just 3 plus 5, which is 8. Another international practice exam question. This one's a little more involved, but it's the same idea as the last one. Okay, we have a function on a closed interval, and they give us the value of 2 definite integrals. So you have the value of the integral from 1 to 7. That's already written the way we want it. And that value is 42. And they give us the value of the integral from 7 to 3. I don't want it written like that. I want it the other way. I want it from 3 to 7. Okay? So if the integral from 7 to 3 of that function is -32, then the value of the integral from 3 to 7 going the other way would be +32. The third piece they give us It seems like they're throwing us a curveball. There's a 2 in the integrand. We're multiplying f of x by 2. So the way that we handle that is we want to take that 2 outside the integral sign. Okay, so the integral from 1 to 3 of 2 times f of x dx is 2 times the integral from 1 to 3 of f of x dx. So basically what we're going to end up doing is finding that yellow highlighted integral and then multiplying it by 2. So how do I do that? I take the interval from 1 to 7 and I break it up into 2 intervals. So I can write that the integral from 1 to 7 is the integral from 1 to 3 plus the integral from 3 to 7. Now they give us 2 of those integrals. They give us the first one, right? The value of that integral is 42. They give us the last one. The value of that integral is 32, which leaves us with solving for what is the integral from 1 to 3 of f of x dx? Well, it's just 42 minus 32, which is 10. So the integral from 1 to 3 of f of x dx is equal to 10. But we're being asked to find 2 times that. So I just take my value of 10, multiply it by 2, and I get 20, which means the answer is D. Okay? So really what we're doing is you're given a bunch of integrals, and you're going to write integrals as the sum of other integrals. Right? Breaking it up into sections. If we want the entire definite integral, we can break that up, sub in the values you know, and solve for the ones you don't know. That's kind of the strategy every time. The next one is a little more involved, so I'll go through this one again with you. This one's a little bit more involved because we're working with 2 functions. And you need to pay attention to that, okay? The first integral we're given is the integral from 0 to 6 of f of x dx, okay? That integral is 9. And then we're given an integral from 3 to 6 of f of x dx. That value is 5, okay? Now it's fine. I'm happy with the way that they're written because they're both integrating from left to right. We're going from a smaller number to a higher number. The third integral we're given is for a different function. It's the integral from 3 to 0 of g of x dx, and that's equal to -7. We typically, I said, write them the other way. So I would like to see, and I've written it down there below, the integral from 0 to 3 of g of x over on the right-hand side is the negative of the integral from 3 to 0. So that would be 7. I just take the -7 and multiply it by 1. So the integral from 0 to 3 of g of x is 7. Okay, then it says, find the value of the integral from 0 to 3 of 1/2 f of x minus 3 times g of x dx. So we've got, it looks like a complicated integral there. So what I've done is I've broken it up into parts, and what happens is one of the integrals we end up with is f of x, and the other one is just g of x. Okay? So you can write that one integral as 2 integrals. And then I took out the 1/2 and I took out the 3. So I can write that as 1/2 the integral from 0 to 3 of f of x dx minus 3 times the integral from 0 to 3 of g of x dx. Okay, so somehow I got to come up with that. So based on what I'm given, I know that the integral from 0 to 6 of f of x dx, I can break that up into 2 parts. It's the sum of the integral from 0 to 3 plus the integral from 3 to 6. Now when I do that, I'm doing that because it will allow me to find what the integral from 0 to 3 is, which is part of what I need. Okay? So now I sub in the numbers I'm given. The integral from 0 to 6 is 9, and the integral from 3 to 6 is 5. So to find the integral from 0 to 3, I just take 9 and subtract 5, and I get 4. Okay, so I've got one piece of the puzzle that I need. I've also got the other piece, because I've already done that. The integral from 0 to 3 is just 7. So now I'm going to use this, the 4 and the 7, and sub it into that expression there that I wrote in red. So 1/2 the integral from 0 to 3 of f of x dx minus 3 times the integral of 0 to 3 g of x dx is just 1/2 of 4. Okay, because the integral from 0 to 3 of f of x dx is 4. Minus 3 times 7, because the integral from 0 to 3 of g of x is 7. And then you just do the math. 1/2 of 4 is 2. 3 times 7 is 21. 2 subtract 21 is negative 19. So a little more involved than the last couple, but the same idea. Any questions on that one? It might take a bit to go through it. You may have to read that a couple of times over to see exactly what's being done, but the strategy is take what you're given and write it like this line here, the integral from 0 to 6. Break that up. And when you do that, it'll allow you to find the missing piece, which will be helpful in solving the problem. Next example, I'm going to leave this for you guys to go through on your own. The solution is there. Okay, see if you can follow that. And so make sure you understand how to do this question. I want to move on because this is similar to the last ones we've done. But it is involved, so please make sure you go through this in detail and you understand it. That brings us to the last two examples that I want to get through. So, this one here, number 9, you're given the graph and you're being asked to express the relationship between those three integrals. The integral from 0 to 2, which is really just the yellow highlighted region there. The integral from 0 to 3, which would be the yellow region subtracted the blue region. And then the integral from 2 to 3 is just the blue region, or the blue area that I've highlighted there. So, which of those three integrals would be the largest? The yellow, the blue, or the net area where you take A1 and you subtract A2? Well, obviously, the yellow one is larger than the blue, and the yellow one will also be larger than the integral from 0 to 3, where you're taking A1 and subtracting A2. So the integral from 0 to 2 is the largest. The integral from 0 to 3, which is when you take A1 and subtract A2, that would be the second largest integral. And then the integral from 2 to 3, which is the blue area, would be the smallest value. It's negative, so obviously it's going to be the smallest. So when you put those in order, your answer would be D. Okay, the integral from 2 to 3 is less than the integral from 0 to 3, which is less than the integral from 0 to 2. So this one, the last one here, this is the largest. Obviously, you can see that from the diagram. And this one would be the smallest. It's the only integral that's negative, right? The integral from 2 to 3 is a negative value. So that's another way you might see a question testing you on properties of integrals. Okay, which leads us to the last question, which in my opinion is probably the most interesting of them all. And I've put a question like this on tests before. I think it's a good question. So, we're given the graph of a function. It's a quarter circle, okay? And then a line that has a slope of -1. The radius of the quarter circle is 3. You can see that from the diagram. And that line that starts at 3 and ends at 7, that straight line which is below the x-axis, that has a slope of -1. That's important. And they're saying let b be a positive number. Okay, b has to be positive, such that if you integrated from 0 to b, and now if b is positive, that means you can only integrate towards the right. So starting at 0 and moving towards the right. We don't know what b is. Our job is to find b, such that if I integrated from 0 to some value b, the value of that integral has to be 0. What is the value of b? In other words, find b. Okay, so when you look at the diagram, you can see that if you're starting at 0 and you're integrating towards the right, the only way we're going to get 0 is by having a negative area, like part of the blue triangle there, canceling out the area that's the quarter circle. So for sure we're going to have to integrate past 3, because the integral from 0 to 3 is just a positive number. It's the area 1 there, that yellow quarter circle. So I need to find some number past 3 that will form a triangle. It's obviously going to form a triangle, such that now that blue shaded triangle has to be equal to the yellow shaded quarter circle. That's the only way that our definite integral is going to be equal to 0. So what I've done there is I randomly drew a dotted line from the x-axis down towards that line with a slope of -1. It doesn't matter where you put that. I just happen to put it between 6 and 7. I don't know where to put it, but that really doesn't matter. I'm just going to let the distance between that dotted line and 3. So starting at 3, the length from 3 to that dotted line, I'm going to call that distance x. Okay? Now, that forms the base of that blue triangle. The height of that blue triangle is also x. The reason that it's also x is because the slope is just -1. Okay? So for every number of units that I go over, I have to go down by the same number of units if I'm going to be on that line. So if I start at 3 and I go over x units, then I'm only going to fall on that line where that red dot is if I go down the same number of units. Okay? That's important. So that triangle has a base and height that's exactly the same length, which is x, because that slope is -1. So basically now I'm going to solve for x by saying that the area of my triangle has to be equal to the area of my quarter circle. That's the only way that we're going to get 0 for a definite integral. So the area of the quarter circle is 9 pi over 4. That's what area 1 is. The area of the blue triangle is 1/2 x times x, which is x squared over 2. So if the integral from 0 to b is going to be equal to 0, then those two areas have to be equal to each other, which means x squared over 2 has to be equal to 9 pi over 4. Okay? Multiply both sides by 2. You get x squared is 9 pi over 2, which means x is 3.7599. That's what x is. So that means if I start at 3, the distance from 3 is 3.7599. That is not the value of b. I have to add 3 to that value, okay? Because I have to integrate from 0 to 3 plus 3.7599. So I get a value of 6.7599, and the closest answer there would be D if I was to round up. Okay, so if I start at 0 and I integrate to 6.76, then that value of the integral will be 0 because the quarter circle area, which is above the x-axis, will be canceled out by the blue shaded triangle area, which is below the x-axis. And that's it. Good question. Any questions on anything we talked about today? Nothing? No questions at all?